Okay, this is activity HR59, and what you see here is a block with the dimensions shown, and the drawing seems to indicate that there are two equal opposite forces acting on both sides, and you're asked to solve this thing without any planes of symmetry and use local mesh refinement on the curved surface. But first of all, you should realize that if the two ends, you apply a load at the two ends as shown here, this is different from saying that one end is clamped and the other end is loaded, okay? Uh, because when you clamp one end, the geometry changes in a different way. However, I'm going to solve this problem exactly like it says, okay, and use no planes of symmetry. Keep in mind that in the class, I did the same problem with multiple planes of symmetry and without one end being clamped. But here is a chance for you to try your own understanding of the problem and repeat it yourself. Okay, so let me go ahead to Catia here and start with the part file. Okay, I'll call it HR59. HR59. Say okay. Immediately save it. So file, save management, save as in a folder on my desktop. I create a folder and I call this thing HR59. Okay, say okay. All right, and let's make it. So, for example, on that vertical plane, I will sketch a rectangle that is 2 by 4, something like that. In inches, of course, so that's going to be 4 inches this way, 4 inches, and 2 inches that way. Yep. Exit and pad it by 10 inches. Is that right? 10 inches, yeah. Pad by 10 inches. All the mirror extend 5 inches in each direction. Okay, good. Now I want a hole drawn there, so on that face we'll sketch a circle and make sure it's exactly halfway between the top and the bottom. The top, control bottom, control the middle point of the center, and you make this thing equidistant. And the radius of that circle is unfortunately the radius is not shown in this drawing. However, I'll make up something. So let's make this thing how about 0.5? The radius 0.5. Let's see, radius of 0.5. Yep. Good. Exit. And we pocket it all the way to the end. Let's see what we can find pocket here. All right. Now we're going to apply material properties on this. So let's make it out of steel. I think that's what the problem statement said. Steel on that part, and then we say okay. Once we do that, then we're going to go to generative structure analysis and simulation, generative structure analysis. Catia immediately measures it as it wants to, and this size that you see here, the size of this element, how does it know what to do? Catia looks at the overall size of the part, and based on that, it comes up with a value. Probably some algorithm is written based on the size, which is 0.1 inches. Now, you are told to make a local mesh deformment around the hole with the default size. Let me remind you how you do local mesh deformment right there. You see in the model manager, if you open this, you're going to get that sub toolbar, and that gives you the local mesh size. There is a number here. How does it know what number to use? This is based on previously, if you use something, it uses that. Otherwise, you just select it and change the number as you want. I don't want this thing. I'll make this thing maybe point 1. See how it looks like, by the way? If you look here, that number was very small. See that? That 0.05 was over there probably. Let's see how it looks like. This is point 1. Okay? And if you want to look at your mesh, put the cursor on nodes and elements, right click mesh visualization. So you're going to get the overall size of the element like that and a final mesh around the hole. Now to do the rest of the problem, you have no choice but to deactivate this mesh. See that mesh here? Right click, deactivate. Okay, good. Now we clamp that in and we are told that there is a pressure of let's see now, 2,000 pounds, or actually there's a force of 2,000 pounds. So there's the force total, this is the force value, force on that face in the direction, in my case, y, 2,000. 2,000 pound lbf. Because my units right now are in newtons, okay? So what I'm going to do is I'm going to change my unit because I have to type 2000 lbf. It converted to unit to newtons. So let's go ahead and change our units. Units, make sure that this is actually 2000 pounds. So we go to tools, options. Okay, my dimensions are on inches. I'm pretty sure about that. You can see that. But the force we find it. Here's the force, we change it to lbf. And pressure, later on, we're going to see it in psi, so let's put it at psi. Good. Now, if you want to make sure that you inputted the right value, double click on that load. There's your 2,000 pounds. Good. That's pretty much it. So let's go ahead and run it. Okay. Let's look at the deformation. Looks like that. You can always animate. You're stretching that. Fine. You can look at the displacements. Select the visualization tab, average ISO, and change the rendering to material shading. This is the displacement, biggest displacement, of course, at this end, because the left hand is fixed. On the right side, you are applying a force, and you look at the von Mises stress, looks like that, okay? And I have to make a few comments here. First of all, the stresses are low. Even the biggest stress, if it was true, it's very low. Okay, low in the sense that the use strength was structural steel about 30,000 psi. This is only 600, 700. Some of this is not realistic either. But let me show you something else, and that is if I want to see my elements, you know what to do. You go to this rendering tab at the very end. See that edges and points are checked, therefore it shows you that. Some of the stuff that I don't need, I can actually hide. For example, I don't want to see that clamp restraint, so I'm going to hide. I don't want to see my load. I'm going to hide the load. I don't want to see that guy sitting there. I'm going to hide that guy. Okay, very good. Now, let's say we concentrate in this area. How do we concentrate in this area? What you do in Catia, you're going to have to create a group. So first, let me deactivate this plot. Deactivate that. Okay, good. And if you don't like this particular rendering, change it to. Okay. So what I did, I kind of moved my part to the left and click on the box group, and then I check this so that I can make a box as I wish. I grab the box and move it and put it where I want it. Obviously, this is not the right spot, so let me move this thing and put it right there. Okay. So I can resize this box so that it gives me the area that I'm looking for. Now, notice that I wanted to make the box a little bit bigger this way, and I don't have to see these ends, so I'm going to get close to the circle, the hole, and then say okay. All right, you might say, okay, so now what? Well, remember I had plotted the Von Mises stress, double click on it, and say, okay, I don't want to see everything, but under the selection tab, see the selection tab here? Just show me the stuff in the box. Don't worry about the rest of the stuff. Right click, hide the box, and you can zoom in, and change the material, change the rendering to material shading, and it kind of lets you put aside all the stuff that happens away from that. All right, folks. So this takes care of this particular activity, and I have already done the case where uh, I did not clamp the left hand. I just, applied different things early in the class. Good luck.